Next speaker is the co-founder and CTO of Redisco and visiting professor at IIT Bombay. With over 20 years in software, he's made a career out of turning messy, complicated ideas into something teams can actually use. Please welcome Navin Kabra.
Thank you. So basically, this is about if you have AI in your program, then all kinds of new problems you have created for yourself, right? And making sure that it works and making sure that it continues to work is a problem. So this new field is emerging of how to do evals for program. How to evaluate the programs which are using AI and how to keep them on track. And it is called evals because it turns out that this is significantly different from doing the same thing for regular programs. This is significantly different from QA and unit testing and things like that. So that is what I'm going to be talking about. Initially, I will talk a little bit about motivation as to why we have to do this, why is all of this different. Then I will talk about the philosophy of evals, as in what is the big picture, what do you have to keep in mind, how do you think about this problem, and only then we will get into the details, and there I will start from simple and go to the more complex things. This is a fairly there's a lot of detail in this area. I have left out most of it. Today, I just want to give you a rough feel for the direction in which things are going and, basically get you interested in looking up more in this area. Of course, you can ask your favorite LLM for details of how to do this. Programming used to be that, you spend a lot of time writing code. And then the good companies spent a good amount of time doing QA. The bad companies, let the customers do the QA. But on an average, I understand that the software industry spends about 1/3 of the time and effort and money on QA and testing. A lot of that changes once you start doing programming with AI, okay? Because what happens is that once there is AI in your program, there's not a lot of programming you have to do, because mostly what you do is you just hook up the input from the user, you send it to an LLM, you get the LLM output, and then use that in your interface, right? Most of the intelligence sort of moves to the LLM, not most of it, but a lot of it moves to the LLM. And then once all of this structure is in place, a lot of the work is basically adjusting your prompts, okay? And that doesn't necessarily need a programmer. But in any case, adjusting the prompts is some amount of work, but it's not the same as programming. Evaluating whether this is working, this is a much bigger problem now, right? Think of why this is a problem. First of all, the output of the LLM is not deterministic, right? The same inputs can produce different outputs on different days. That is one. Second is typically, depending on what you are doing, sometimes the output is structured output and you're getting JSON and so on. But a lot of the times you're using LLMs in situations where the output is also English text or fairly subjective. And then there are just so many different ways of saying the same thing. As a QA person, how do you check this, right? How do you write an automated test to check whether an English sentence says what it is saying? The second big problem is the fact that the input itself is not fixed, because typically, again, if an AI has been incorporated in your program, you're going to allow the user to type in text or take free text from the user. You have a system which allows the user to ask questions in English and convert it to SQL. The user can say anything, right? Again, no fixed, there are not specific boxes with inputs and specific buttons to click. There is just text, and the user can put in a poem, user can start whining about something unrelated, and you need to be able to handle all of that, right? So the inputs are not deterministic either, plus the inputs are not only from a specific area. So that's the other big problem. And the third big problem is the fact that Just because it is working today doesn't mean it will work tomorrow. The models change, the kind of users change, the kind of language users are using will change, the amount of time you give to the LLM. If you change that, the output changes. So many different things can change. And fourth is that, again, typical programs, when you are doing QA, you have an input, you do click, 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 feed this, and then see if the output came out, right? Whereas, again, a lot of LLM-based programs will have a fairly long list. There can be long interactions with the LLM. There can be entire conversations, and things can go wrong anywhere in the conversation. So how do you check that, right? So what I'm going to do is I'm going to use a running example so that I can give you concrete examples of the concepts I'm talking about. Okay, the example is that there is a program which is an LLM based AI interviewer for job candidates. Okay, so there is job description, there is, which is basically list of requirements. There is an evaluation criteria which the hiring manager has given, saying that I need at least 8 on 10 on Python, and I need the English comprehension skills to be at least 6 on 10, and things, something, whatever, right? So there is input is JD, input is evaluation criteria. Then there is the resume of the candidate. Based on this, the LLM is going to ask questions to the candidate. Candidate will answer questions. That will go on for maybe half an hour. And at the end of it, the LLM produces an evaluation. Okay. Based on this evaluation, the company hopes that you will shortlist some candidates and reject a bunch of candidates. This system is what you want to check. This is what you want to evaluate. Okay. So the first question, and just to give you an example of this, is the final output of the example program that I'm going to talk about, right? So how do you start evaluating something like that? You have done these kinds of things, so let's talk about that. Where does the golden data set come from? In this particular case, what would be a golden data set? Okay, so this is an important question. Okay, one part of the answer is correct. There needs to be a golden data set, which is a data set of correct behavior against which you test whether any new model, any new prompt that you have set up, is it doing the right things for the golden data set. First question is, where does the golden data set come from? And depending on each application, what constitutes a golden data set also can be a little tricky to figure out. Let's just ask the question, what does a golden data set mean in this particular case? Pre-evaluated candidates, right? So there is a problem here, right? Which is that, there is pre-evaluated candidates, but now the LLM, which was supposed to interview the candidate, cannot interview this pre-evaluated candidates. So part of it can do. So after looking at an interview, the final evaluation you can get the LLM to do. But for the actual interaction with the candidate, it cannot do, right? In terms of doing evaluation. Okay, so basically the thing is that just simple things like number of years of experience and coding and so on, we can test the very basics of did the LLM even extract that correctly, right? So we will come to that. That's a good point. The evaluation criteria can be simple all the way to complex. What else do you do other than a golden data set? How do you evaluate a system like this? What I have seen in practice when a company initially starts implementing something like this is that the developer will have 4 or 5 sample scenarios in mind, and every time development is complete or you change to a new model or you tweak the prompt, the developer will go through those and see if the output that came out is reasonable, right? This is like the old days of programming before we invented unit tests, before we invented CI/CD and so on. We have a lot of experience to know that that is just a very bad idea, right? That is not the right way to QA. That is the right way to say, okay, this code seems to be okay. Now we need to look at it in more detail. Okay, so let's look at what we need to do. Let's suppose you wanted to automate the evaluation of a system like this. What should the metrics be? I mean, number of test cases passed is a very simple metric. But inside that, what does pass mean? Because if if one case happens to be an entire entire interview, then what kind of metrics should you have, right? That is also a difficult question. Should it be that just did the final evaluation 4 by 6 of the candidate, did it match a human's evaluation, or does it mean that all the details of the evaluation have to match that of a human, or is it that it correctly asked appropriate questions, or is it that did it ask follow-up questions, so on, right? You can imagine that metrics itself is a fairly complex area, right? Another question is, how many test cases should you have? So before diving into the details of evals, I want to talk about the big picture questions of what is the philosophy of evals. Okay, so most important thing is start small but start early, because what happens in many companies is that once somebody starts asking the questions like I was asking, you realize that this is a very big job, it is a very complicated job, and then you just give up, right? So you just don't implement any formal system for evals. What you do is you stick with your developer checking 5 things, and if it is late at night on a Friday, then developer will check only 2 things, not even the 5 things. So to avoid falling into this trap that this is too big of a job and it is going to take a big effort, so when at some later point we will implement a full-fledged proper eval system, but for now nothing, that is not the right way to do it. Start small, start something very trivial, but have an automated end-to-end test, so that after every code change, after every prompt change, after every model change, you can click one button and you can see tests pass or fail, just like you do your regular unit tests. Okay, so I'll give examples of what does start small mean. Okay, so that is because, as we like to say in Pune, something is better than ajibat nothing. Even the 5 test cases which your developer was doing, even those are fine, but automate them, or at least, and you can't automate everything because the developer is going to be using human judgment there, and you can't automate that part of it. So, but automate simpler things, which I'll give examples of, and very crude metrics are also fine. Again, that is a very big problem, and if you start thinking too much about what to measure, what should the metrics be, you will get analysis paralysis, you will not implement anything. So start with dumb metrics, and over time you can slowly improve them. The metrics can be unoptimized, they can be just a subset of all the metrics that you are interested in, and they can be vaguely correlated with true performance. They don't have to be an exact match. Again, I'll show examples of that later. Most important is get something working, and then over time you can iteratively improve it a little bit. So to be able to start with crude and simple tests and then later on make it better, you have to think of something called a ladder of AI capabilities. AI capabilities can be something very simple to fairly complex. So you can start with just testing for the simple things and then go to the complex things. Okay, so the simple one in this case would be, did it just conduct a coherent interview, right? And by coherent, I'm not even thinking in terms of was the content of the questions reasonable and what the content of the answers reasonable and so on. Yeah, the lowest level of the ladder is, was there an alternation of questions and answers, and did the whole thing end without crashing or without getting stuck in a loop or without the candidate quitting in frustration? Forget the content of the interview. Did the whole thing just go through and follow the steps? Okay, that would be the zero thing. And your initial evals could just be that, as in, did 100% of the situations complete like this? Okay, the next level would be, did it produce an output that made sense? Okay, I'm not asking about did it produce correct output. I just said, did it produce an output which is in the correct format? Did it say that, oh, this candidate should be shortlisted or should be rejected? Right, that is what we want out of it, right? So whatever is the format of the output, did it just produce that? without worrying about whether that evaluation was correct or not. Next level is forget the final evaluation of shortlist or reject. At least did it identify the skills correctly? Did it focus on Python and Django and SQL? Did it focus on PHP and Drupal, right? Or did it go off on random and ask questions about something else entirely? Then for each of the criteria, did it evaluate on the correct criteria? Then the next question really, which is that its evaluation, did it match the evaluation of the human judges? And then the final real thing, which is ultimately, did this improve the business outcome, right? The final output of your AI is not a correct assessment of whether the candidate should be shortlisted or not. The final outcome is something for the business. Things like that we hired more candidates in a month than before, or the candidates that we hired, retention has increased, right? We didn't have to fire anybody for 6 months after that. Things like that. Those are the real outcomes which developers often tend to forget, but that is something we have to worry about, because one thing that happens is that when you replace humans with AI, the AI can be made to match the steps that the humans were following. But because humans have unsaid things, they can take decisions without explicitly mentioning that, oh, they might have rejected some candidate because of some criterion in their head, which they had not mentioned anywhere in the documentation. And that is what was really leading to good results. When you replace that human with an AI, that criterion is gone and everything matches, but the business outcomes might be wrong, right? So you have to keep that in mind. So this is the big picture philosophy. The other thing to keep in mind is that software roadmaps are now very different from before. Earlier, there would be a list of features, and then you would give a roadmap that this one will be complete by December, this one will be complete by February, and so on. Doesn't really work in the age of AI, because in the old way of doing things, once you looked at a feature, you knew, you pretty much, if it made it on your roadmap, you knew how to do it, you knew it could be done. You're not taking on something which is a research problem. But in this new world, you are saying, okay, I'm going to try to do interviews using AI. You have no idea whether the AI will work or not. You have no idea how much hallucination will be. You have no idea what is the cost going to be. So you cannot promise anything reliably in terms of this will be ready by so and so date. The only thing you can promise is that these are the capabilities that we are going to experiment with, and we'll see what happens. Now, this is a big change from, managing the managers' perspective, because managers might not have caught on to this change in how life is, right? So this is something that has to change inside the company. There has to be a culture of experimentation, and by experimentation, I mean running it not like an engineering org, but as a research organization, which means that there are going to be lots of experiments, lots of failures, and then suddenly one day it works. And in all of this, I said there has to be iteration, right? So there are 2 real cycles of iteration, 2 or 3 going on. So one is that you implement a product and there is AI in it, and it works at some level. So you have to monitor it continuously. And the only way to check whether it is doing a good job or not is to involve humans in the process. The humans will look at what the AI is doing, and the humans will point to problems. And using that, you keep improving the AI. You change the prompt, you change the product. So human evals is being used to improve the product. That is one cycle. The second cycle, you can't have humans doing this all the time. Okay, they will quit. Okay, and the whole point of using the AI was to reduce the work of the humans. So now you have to introduce automated evals, and we have to invent new ways of doing it, because the old way of automated tests doesn't work in this new system because of all the indeterminate, basically it is not deterministic, right? So create automated evals and then use the human evals to improve the automated evals, right? So you're using evals to improve the product, and you're using humans to improve the evals now. And you now start using the humans to monitor production. So you have to output logs from the product. You have to capture traces of every conversation that happened between AI and a user, and then humans have to look at that for errors, and that anytime you find an error, it has to feed into these two cycles. So the way this works is that initially the amount of manual human oversight is very high. Okay, humans have to be looking at everything that the AI is doing, and then slowly over time you can add automation, you can improve the accuracy of the automation, and then the need for human evals goes down. It never becomes zero. Okay, you can never trust an AI and LLM 100%, so the humans always have to be involved. But if you do it right, if you create a right kind of hierarchy of at the base level AI doing the work, above it AI checking the AI doing the work, above that the human checking the AI, and so on, right? So in all of this, try to have this whole process, most of it automated, and the human parts of it, make it a daily ritual so that the humans spend maybe half an hour every day doing this. And only then will you end up with a situation where there is continuous improvement over time. And on day one, it might not be a great system. Day one, it might be a great system. Okay, the AI implementations are excellent. Problem is that it can be very unreliable, and you don't know what are all the ways in which it can break. But over a period of time, 6 months, 9 months, 10 months, using this process and using a daily check, daily monitoring, daily improvement, you can significantly improve the accuracy of your and reliability. I mean, confidence you have in your product. So I'm going to pause here for a minute. This is the big picture. I'm now going to get into the details of how you do this. All of this was very high level philosophic hand waving. Okay, so let's get into the details. Okay, so lowest level is still unit tests. Okay, and by unit tests, what I mean are a fully automated test suite which you run, and what that is doing is it has code with asserts in them, and if the assert failed, the test has failed, right? So a product might have 200 tests, 500 tests, and out of that, so many passed, so many fails, that sort of thing. Later on top of the asserts, you have a smaller number of subjective evaluations. By subjective, what I mean is that evaluations where it is not an assert, there is some subjective output, and then there has to be some subjective way of judging whether the output is good or bad. Okay, and then at the top, we have A/B testing, because that's the only way to check the business outcomes that I was talking about. Okay, so we'll focus more on level 1 and 2. Again, now when you are looking at these, as we go from simple to complex, keep in mind the hierarchy, the ladder of capabilities, right? If you look at this, the asserts that I have is just ridiculously trivial, right? That in the output, did it just mention role? Did it mention candidate? Was the word overall decision found in the output? Did it say pass or fail? Was it there in the output? And things like that, right? So you will notice that this is level 0, I mean the lowest level of the capabilities ladder. Surprisingly, even this can be very useful, okay, because you have a bunch of tests like this. Every time you make any little tweak, you just run it, and if any of these fails, something has gone seriously wrong and you need to fix it. Because every once in a while you get an LLM which produces some junk output, which produces JSON which doesn't parse, and things like that. Okay, so this is the start simple part of things. The kinds of assert don't have to be just did you see this keyword in there, right? There can be count. I mean, did it ask at least 10 questions to the candidate? I mean, you might have a situation where the LLM asked 2 questions and then returned saying that this is a good candidate. Now, anybody can say that this is not a very good way to evaluate whether the LLM is doing a good job, right? Point is not to have an optimal or a perfect measure. A point is to have a measure which is roughly correlated with good human decisions, right? I mean, is it possible that there is evaluation, an interview by a human which was only 9 questions long, and they said yes to the candidate and it was an excellent interview? Yes, it is possible. chances are low. On the other hand, is it possible that, most of the decent interviews went for 10 questions or more? Correlation, that is what matters. You are not looking for a perfect match. Okay, things that are roughly correlated with good outputs are okay to include as tests. You can do keywords, you can even do regular expressions. Okay, so was system design or architecture or scalable or scalability, was any of those mentioned? If none of those was mentioned, does it mean this is a bad eval? No. It just means that some human has to now go and look at it, because it is possible that the AI conducted an entire interview without asking about system design and scalability. So this is the lowest level. You should have a large number of such asserts. Now, the important thing to keep in mind is that these have to be fast and cheap. These do not have to all pass. Okay, you have to change your mindset. When you are doing unit tests in a regular program, you want 100% tests to pass. Okay, that's how the world is, because you write it in such a way that it's going to pass. Whereas in our case, we are looking for rough correlations. 100% of them will not pass, but that is okay. They must be fast and cheap. The other thing to keep in mind is that when you are doing an evaluation, everything is part of the thing being tested, right? Resume, JD, evaluation criteria, these are all inputs and they are part of the test case, right? I mean, you need to be able to test that. If I gave a completely irrelevant JD, then what happens? If I gave evaluation criteria which had some error in them, right? Or if by mistake I use the evaluation criteria of a different job, what will happen? Things like that are part of what you should be testing for. Okay, don't wait for real world data. Where does the gold standard data come from? Okay, that's another big thing. Initially, like I said, developers will have 5 cases that they just dream up by themselves. That is fine, but one of the most interesting ways of doing this is to use LLMs to generate synthetic data, right? So if you describe the whole situation to ChatGPT and say, I want to create test data for this, ChatGPT will come up with, okay, here is a potential resume, here is a potential JD, here is a potential this, and so on. So it can generate all the test cases for you, and you can't use it directly. Okay, then the human has to look at what ChatGPT generated, keep the good ones, throw away the bad ones. But still, your ability to create tests goes up significantly. And ChatGPT can generate everything, right? The resume, the JD, the evaluation criteria, the assert that you should have around it, all of those. Because the assert, the examples that I gave, if you give those examples to ChatGPT, it will come up with 20 other possibilities that you didn't even think of. And you can, of course, mix real data that you have with synthetic data to get even more test cases. Business decides what is an acceptable pass rate. Okay, not everything has to pass. This is a big difference from regular programs. Okay, now developers might not necessarily have a good intuition for, okay, is a 80% accuracy rate okay for this program or not? Okay, but business is much better at figuring this out, because you are not developers by instinct tend to compare this thing with the perfect version. Business knows that if I don't have this, what is the alternative? Either I don't do an evaluation at all, or I just reject a whole bunch of candidates without even looking at having an interview. I reject based on keywords which will be generated by a low paid recruiter, things like that, right? Business has a fairly decent idea of the alternative, how much worse the alternative is. So business would be able to say, you know what, give me 80%, that is good enough. So keep that in mind, right? Have some percentage, not 100%, but which is acceptable to the business at this level of cost and expense. And then create a dashboard which will track the pass rate over time. So I'm going to go a little faster. In production, what you want to do, the thing about AI-based programs is that normally you would do QA, and once QA says this is QA okays a program, then it gets released. Then QA goes off to work on the next version of the program. You don't do QA on a program which has already been released. That is not true of a program with AI. QA Evals have to be happening continuously, especially in production, because you can never guarantee it will not make an error. And if it makes an error, that is going to be much more catastrophic, right? So you have to be monitoring production. And whenever you see an error you will see errors in production, because remember, we said 80% rate is good enough. Business told you. So every time you see an error in production, you have to study it, analyze it, figure out how you can change your AI, your prompt, your model, anything to make that error go away. And that should get incorporated as one of your tests. So error analysis becomes a very important part of this. What does error analysis mean? So you have to monitor production. What your program should do is it should log traces. What traces means in this field is that entire conversation. And this needs to be logged, and then you need to make it really easy for a human to look at traces of what's going on in production. Okay, depending on your volumes that your system sees, it might not be practical to see all traces, but there should be some sampling that you do based on whatever criteria business can help you decide. But sample some of the traces, and every day some traces need to be looked at by somebody. What are you doing is that basically a human is looking at the entire trace, and human should be able to click at one point and say, you know what, the LLM made a mistake here. And short label, subjective. Okay, this is not a, I mean, beforehand, because every implementation is different, every problem you're trying to solve is different, the kind of errors that an AI in interviewing makes will be very different from the kind of errors an AI that is generating SQL makes, right? So you don't want to have error categories defined upfront. What you want is humans adding a one-line text saying that, you know, here it asked questions that are irrelevant to this candidate, or it didn't understand a sentence that, a word that the candidate said in Hindi, or something like that, right? You keep adding errors, and what will happen is that over time, you start seeing patterns. I mean, there will be some errors, of course, which are just weird one-off cases. But over time, you will see that there will be top 3 or 4 categories of errors will emerge as the most common cases, and it will be a power law. So what you can then do is that it makes this error, 40% of my errors are because of X. So now you can go and work on X. Important is that you need to have specialized tools for error analysis and allowing the human to look at all of this, right? You cannot have them just say, okay, here is a log file, go through it. That doesn't work. Or even trying to put it into existing tools, put it in Asana or Jira or something like that. That is just going to take too long, too many clicks. It will not be a good match. And what you want to do is you want this to be an easy activity for the humans. Every little click, every extra click adds to the friction and will make them more irritated. So what you have to do is you have to create specialized tools, specialized interface just for looking at these traces, and use LLM vibe code tools with the exact customized interface that you need. It will take less than a day, okay, to create specialized tools like that. And these tools, so this is an example of the kind of tool that you would end up with for the interviewing use case, okay. What you see is that this is one trace, okay. What the tool has done is it has pulled out data from production. Some data has come from the database, some has come from the log files, some has come from the final output, and so on. But the tool has put it in a way where it is very easy to see. Left-hand side is the candidate requirements, middle is the job requirements, right-hand side is the transcript of the interview conducted by the AI, and then at the bottom, just this box, the human who is evaluating this error needs to be able to do just 2 simple things. One is that did the AI do a good job or bad job? So single binary outcome, okay. Don't make them choose from drop downs and this and that and ask them to give a score from 1 to 7. They hate that. Second is allow them to write a few words or a sentence explaining what exactly happened, what did the AI get wrong. And the reason is, so what is happening here? all the context is in one place. Just one glance at the screen and the human can, within seconds in fact, decide whether the AI did a good job or bad job, minimizes the number of clicks per trace. You have to have space for open-ended feedback. I'll talk about that why later. And have hotkeys. You don't want people to be using the mouse, because if you're doing this every day, people get used to hotkeys, and that is much, much, much faster. And you will be surprised at how many traces a human can go through in, say, just half an hour every day if you do things like this. The increase in productivity is huge. The other things in this tool, the reason it is a specialized tool is because I can just, in here, I can say that, I can click one of these and say, well, this particular interview did not test communication skills, it tested this, it did not test this. And all of that gets captured as error analysis, which will be used later on to improve the program. In the interview transcript, I can highlight something and then mark it, saying that this is where the problem was. Who should do this analysis? Usually, we give QA to the least paid person in the company, okay? Unfortunately, that's will not help you improve the program, okay? Because you want to use the domain expert. So in this case, it's not even the developer, nobody in the engineering organization. It is somebody in the hiring manager or someone there, right? Depending on your, if I was doing the case where questions are being converted into SQL queries, then the people who are using it should be the ones evaluating, not the SQL expert. The user of that tool, the one, maybe the guy doing marketing analysis, that should be the person doing the analysis, right? Because that can capture unspoken requirements, and that is fairly important. And you can involve them in improving the prompts also. The thing is, in the old days, they didn't understand programs, they couldn't edit programs. So they were forced to give their requirements to a product manager. The product manager will translate to developer language. Developers will translate to QA language. None of that is needed, right? You can expose the prompts directly to the expert and have them suggest changes. Again, same thing, okay? This kind of stuff, error analysis, you have to do a lot when a new version has come out. Over time, you can reduce it, okay? But never a zero. Once you have done some basic error analysis, you can use LLM as a judge. The idea being that typically in production, the LLM that you use isn't the most powerful one because it is expensive and because it is slow. So in production, you'll have a fast, cheap LLM. But in QA, when you're doing evals, you can afford to use the top model, ChatGPT 5.1, Thinking Pro, whatever. So using that, you can check whether the fast and cheap LLM did a good job or not. And then you still can't trust it, right? So you have to check whether a human agrees with the LLM as judge. So what you do is that create an Excel spreadsheet where first column is output of the software. The basic LLM usage, it has produced the evaluation of the candidate. Next two columns are output of the LLM as judge. So here the LLM as judge is saying that yes, this did a good job. The AI did a good job. Now I send this spreadsheet to Rahul. It will have, say, 20 entries every day. And Rahul is supposed to fill the next two columns saying, you know what, I agree with the LLM as judge, or I disagree with the LLM as judge. If you disagree, you have to give a sentence explaining why. Okay, and that's it. So every day Rahul goes through 20 of these. In the last column, you check what fraction of the times did Rahul disagree with LLM as judge. I want to repeat again that this is not evaluation of your software, the AI in the software. This is evaluation of LLM as judge, which is being used to run tests against the LLM as software, right? And over time, you want this agreement percentage to go up. And then finally, after you have done all of this, then you can introduce A/B testing in your software to see how the business outcomes are going up. So this is it. This is the summary of my talk. Okay, thank you.